We're looking at number 34. We're doing 31st. So the contact rate in 19 was 69% in 1997 and 76% in 2003. And the cooperation rate, in other words, the willingness of the person to conduct the interview once they've been contacted, was 58% in 97 and dropped to 38% in 2003. So the question is, what is the probability in 2003? And just as important, we need to know what's the probability in 1997 of obtaining an interview, the next household on the sample list. So I made a table. We have the probability of contact in 1997, which is 69% or 0.69. Probability of contact, that is getting them on the phone, in 2003 is 0.76. The probability that they agree to be interviewed in 1997 was 0.58. The probability that they agree to be interviewed in 2003 is 0.38. Now, we want to know the probability that you've contacted them and agreed that they've agreed to be interviewed. So that's probability of C and A, probability of contact and agreement. That's what this symbol, this set of symbols here means. P parenthesis C, and then this is the symbol for and A. Okay, so that would be, since it's and, now we have to make an assumption. We're going to assuming that these two things are independent. Actually, it's probably highly unlikely that they're not, except that the contact rate seems to be going up, but the agreement rate's going down. So maybe they're not. Maybe they are independent. I don't know. But anyway, we're going to assume they're independent for this exercise. So the probability of C and A equals the probability of C times the probability of A if C and A are independent. So we're assuming that they're independent. So 0.69 times 0.58 is 0.4002. So in 1997, the probability that you get somebody to do a survey, at least according to these numbers, is around 40%. In 2003, you have an agreement rate of just 38%. So you got 0.76 times 0.38 for a survey. You're going to a positive survey rate of around a little bit less than 30%. So we've answered the questions: what is the probability of agreement, of contact and agreement, for the 2 years, 97 and 2003, around 40%, a little less than 30%. So the probability of contact, of actually getting an interview done, is higher. The probability of an interview is higher in 1997. So that's 30. 34. Okay, donating blood. Okay, so in the previous exercise, 32, we calculated the probabilities of donating blood and so on. Okay, blood type probabilities are disjoint. What does that mean? You can only have one type to the exclusion of all other types. You can't have two different kinds of blood. Disjoint probabilities cannot be independent, since being one type affects the probability of being anything else. So if you're type A, then your probability that you're type A is 100%, and the probability that you're any other type, B, O, A positive, whatever, is 0. On the other hand, if you're type B, the probability that you're A is 0, and the probability that you're B is 100%. So disjoint probabilities cannot be independent, since being one type affects the probability of being anything else. However, B, individual persons arriving randomly to give blood have blood types independent of each other. One person's blood type has no effect on another's. That's assuming that the donors are random and independent, which is, we don't have a club of people showing up that are all type A or something like that. Okay, so that's it for 30 and 34.